So tonight we're going to be going through some ideas in terms of preparation for the INCOSE CEP exam. And um, my sense is, navigating the path can be very complicated, whether you're seeking like the associate system engineering professional, the ASEP, or the CSEP. But it is a significant career milestone, and I think it's an important achievement to have. So I'm going to try to provide a step-by-step roadmap. I'll give you some study plans. I'll point out the parts of the handbook that you really need to know carefully. I'll talk about the exam structure, etc. And I won't discuss a lot about completing the application. I think it's pretty straightforward. It just takes a little bit of time if you're going for the CSEP. But hopefully, if you follow all this guidance, you'll be able to get success on your first attempt, and hopefully I'll make this an easier process for you. My background, I'm currently the executive director of Caltech Center for Technology and Management Education. The center is Caltech's professional and executive training group, so we do about 300 courses a year. We primarily work with companies, about 12 companies, but we also have a lot of public programs, and I'll tell you about those at the very end here. I've been a practicing systems engineer, started out as a systems engineer out of college, spent most of my career as a systems engineer working not only aerospace and defense, but commercial companies as well. I've also been heavily involved with INCOSE, and I'm an extreme supporter of INCOSE. I was past president of the Los Angeles chapter and on their board of directors for many years. I am still currently an assistant editor for the INCOSE Systems Engineering Body of Knowledge, the CBOK, and I was privileged to win an award for my years of service there. So hopefully I can give you some inside information about what it takes to pass the exam. There are 3 certification levels at INCOSE, the ASEP, the CSEP, and the ESEP. ASEP is designed for somebody typically right out of college. That is somebody without a lot of experience. And if you take the exam and seek your ASEP certification, you're basically letting the world know that you have some knowledge in terms of systems engineering. CSEP is designed for people that have some professional years of experience, typically 5 years, and it's both certifying both knowledge and that experience, and you prove that experience by basically asking for 3 references, people that can cover all the years of experience that you're claiming. And then those of us who've been in the industry for a long time, 25 years or more, can seek the ESEP. If you're lucky enough to be in that category, it's simply filling out a long application and giving 3 references that cover the last 10 years. And you don't need to take the exam. It's the same exam for ASEP or CSEP. If you've got close to you've got 5 years, maybe some of it's not directly system engineering experience, I would probably still apply for the CSEP, etc. And then one final thing, I know this group is about preparing, but there also is a way to bypass the exam, and I'll explain that at the end, but it's something called academic equivalency. If you take training from an academic equivalency partner like Caltech, for example, we're one, if you take certain kinds of courses, then you don't even have to take the exam. So that's always an option, or if you run out of time, or you just find taking the exam frustrating, or you just maybe haven't had formal system engineering training you'd like to. We'll talk about those options at the very end. So what's the exam composed of? Well, it's 100, 120, or 150 multiple questions. It's all based on the INCOSE Systems Engineering Handbook, and it's currently based on the 5th edition. Now, the reason why they have more than 100 questions sometimes is INCOSE likes to throw in kind of practice questions or potential questions that they might ask just to see how you do. So it would typically get a 120 question exam, but only 100 of those are the true questions. The rest are just kind of survey questions. Each multiple question has 1 right answer, so you're looking for the answer, typically out of 4. And the exam is timed. You're going to be given 1 minute per question. So if you have 120 questions, which is pretty typical, you'll get 120 minutes to take the exam. The biggest challenge, I think, for a lot of people is you have to take the exam at a proctored location. Means you have to go to a specific location. There are plenty of them. There's a group called Pearson VUE that does the proctoring, and you go and take them. You're often sitting in a big room with lots of other people, and they're taking other exams as well too. These are just kind of exam locations. You could take the exam by computer or by paper. Really, it's no difference in the exam. Same questions, same time, etc. You have the opportunity to go back and change your answers if you want to, both with paper and computer. If you take a computer exam, then you can you'll have like an online scratch paper if you want to write some notes. Sometimes there are calculations involved, and you can use that scratch area, but you can't use any physical paper. If you do write on anything, or you make computer files, you do have to throw those away after the exam. You can't record questions and give them to your friends or something. The biggest problem is the exam is closed book. So I think for a lot of people, the exam is really a test of their memory, test of how well they can memorize various sections. And some parts of the handbook may be unfamiliar to you, but if you're going to take the exam, you really want to memorize a bunch of chunks of the exam, and I'll talk to you about that. By the way, I'm happy to answer questions as we go. Just don't hesitate to throw something in the chat window, and I'll stop and address the questions for you here. Or if you'd rather unmute yourself and ask a question, I'll also leave some time at the end to ask questions as well. And we have these slides are all being made available to you. They'll be posted for you to be able to access it. Okay, let's look at some potentially sample questions. Now, I want to say these are not necessarily the real questions. I'm not an examiner. I didn't write questions, but I do know the type of questions that they ask here. So let's look at the first one. In the area of system engineering definition, what statement best describes systems engineering? Yeah, so everybody take a look at it. Maybe if you feel like it, put in your chat what you think the right answer is. A, process of designing system hardware and software components. B, interdisciplinary approach used to realize successful systems. C, a methodology to manage software development problem. D, a life cycle framework used to perform verification testing. Okay, so those of you who put B, that's correct. I think if you thought it might be A, that's sort of correct, but if you really look at the definitions that are in the handbook, it's going to be B. Okay, let's look at question 2 on stakeholder needs. During which lifecycle activity are stakeholder needs primarily identified and analyzed? System verification, system validation, stakeholder needs definition, system integration. Okay, so for this, you'd have to know how the lifecycle activities are identified in the handbook. All right, and if you did, you'd know it C. And I think that's one of the keys when you're studying, and we'll go over this a little bit later on in the charts. You really want to know all the processes. What's the purpose of every process? And there's about 40 of them to learn, and because you're going to get a lot of these questions. In what activity do we do X? Let's try question 3 here. Verification versus validation. What's the primary difference between verification and validation? A, verification confirms stakeholder needs. Validation confirms requirements. B, verification confirms requirements are satisfied. Validation confirms the system meets the stakeholder needs. C, verification occurs before requirements are defined. Or D, validation replaces verification when testing is complete. Okay, so I think this is a tricky one. The right answer is B. Okay, but I have worked in organizations that use the terms exactly backwards or in other ways. So I think one of the takeaways from this is remember that you're being tested on the handbook, not the knowledge you've gained in industry. So one of the things you have to do is just forget all the terms that your organization uses or your university taught, and make sure, especially if that term is used differently in the handbook, that you answer in terms of the handbook's definition. It's not, the exam is just testing you purely from a knowledge perspective on the handbook. It's not testing what knowledge you've acquired in industry, even if you're going for your CSEP. So I think there's a recommended sequence for doing the ASEP or CSEP certification. And I want to walk you through it a little bit and kind of why I suggest that you use this sequence. First of all, create an individual INCOSE membership. You're gonna have to pay annual dues. It's $175, or there might be other categories that would reduce that for you. You don't really have to do that, but there's a lot of advantages. And what we're going to see is it's going to reduce the cost of other things that you want to do as well. Okay, so you get a discount on the exam and the application fees. You get a discount. You get to get the handbook for free, etc. So it really is very cost effective, and you're going to have to join INCOSE at some point to be able to actually get your certification. So you might as well do it now if you can. Some of you might work for organizations that have something called a corporate advisory account, a CAB account. Typically, when you have a CAB account, you can access things like the documentation, like the handbook, etc. If you have a CAB account, that's great. You could probably put off joining INCOSE for a little bit and still get a hold of the handbook. But you're not going to qualify for member pricing. So it's still going to be cheaper to join right up front if your real goal is to get the certification. Step number 2, download and study the INCOSE Systems Engineering Handbook 5th edition. So if you joined in step 1, you'll be able to get that handbook for free. Now there's hundreds of other INCOSE documents. It's very, very useful. I would join INCOSE if only to get a hold of all the really great documentation that they have. But for your purposes, the most important thing is you get the handbook for free electronically. So I think that's good. And don't worry about other things. You don't need to know anything other than the handbook. All the questions that you get on the exam will be on the handbook, someplace covered in its 400 pages. Step 3, create a profile in the INCOSE certification portal and register for the certification exam. So if you go to the portal, you'll be able to say, hey, I'm interested in certification and I want to register for the exam. And so you're going to select a testing date and a location through the exam provider. Hopefully there's one nearby for you. The provider is called Pearson VUE, and they have lots and lots of exam locations all around. Also, sometimes if you go to a certain INCOSE events, the organizers of the event will make plans to have a certification exam there too. So always look for that opportunity. The exam fee, whether you take it at an INCOSE event or you take it at a Pearson site, is going to be about $80. Step 5, take and pass the certification exam. Hopefully following the guidance here, that'll be great. You'll pass the first time. If you did fail, you would have to take the exam again, and you'd have to pay the $80 exam fee again. 6 is once you've passed the exam, then you submit the certification application. You have to do that within 12 months of passing the exam, and you simply log back into your profile on the portal. You navigate to the certification section. You suggest which application you want, and you pay a one-time application fee. For most of people, that's going to be $180 US. If you are going for your CSEP, then you also need to prove your experience. So you'll complete something called an individual application form. This is where you document all your systems engineering experience. Okay, I worked at this company on these projects in these areas. I worked at this company on these projects from this time to this time on these areas. They want to see what experience you've had. It could all be in one specific process of the INCOSE processes, but they want to see that you've got experience. And then you're going to provide at least 3 professional references. INCOSE is going to send them some paperwork, and they're going to fill it out. It's not too much of a burden for them. I've served as a professional reference for several of my students. Not terribly difficult. you complete that, and they'll complete that and turn that in. With a passed exam, with a completed application, with your professional references, if you're going for your CSEP, INCOSE has a full package. They'll review that, and you'll receive an email confirmation that you're now ASEP or CSEP certified engineering professional, and you will get a digital certificate that you can post to LinkedIn or any other social media website. Any questions about the recommended sequence from anybody? All right, let's look at the exam content now. As we discussed, it's all out of the handbook. If you look at the handbook, there's going to be a lot of sections that are going to feel very straightforward to you, depending on how much systems engineering training you've had in college or through your employer, or how much you've gotten on the job. And then there's going to be some stuff that's just kind of new, things that maybe areas of system engineering that you haven't worked in, or you haven't been exposed to in any of your classes. So again, you want to know all of this. It's 350 pages or so. So it's quite extensive body of work. I'm going to try in the next couple of charts to show you the places that I would suggest that you focus your time and energy to do the bang for the buck. You don't need a perfect score on the exam. I think they change it from time to time what the winning score is, but you do want to do as well as possible. You will not get your certification if you end up guessing at a majority of the questions. Okay, a couple ways to look at this. There are parts of the handbook that are more important. And so what I've tried to map here's 25 concepts that I would think would be most likely to appear on the exam. And a lot of them are very straightforward, things like definitions of systems engineering. There's a lot of focus on the V model and, requirements and architecture and design and interfaces and integration, et cetera. Risk management gets a lot of attention on the exam. Other things that you may not have a lot of involvement. You might be involved with measurement processes, or you might not know how INCOSE looks at it. Same way quality assurance might be an area. There's a little bit of systems, right? And there's quite a bit of stuff on technical management. We're going to talk about that in just a second here. So again, it's going to take some memorization of what's in the handbook in addition to whatever personal experience that you have. And sometimes the personal experience will mess you up because the terminology that they use or the way your company organizes the process is not the same as the way INCOSE looks at it. So again, remember you're being tested to the handbook itself. So what would I recommend that you study? So first of all, focus on the processes that are defined in ISO 15288. And we'll show you those in just a second, especially the technical processes. These are the main processes of the system engineering V model and technical management process. And we're going to look at all of that in just a second. Out of those processes, I think some are more complicated, more essential to systems engineering, and they're more likely to show up on the exam. So there are 3 processes associated with system definition. Those are very high priority. That's the guts, and some of the terminology is going to be different there. There is a section on risk management. The INCOSE's view is that systems engineers are heavily involved in the risk management process. That fits a lot of the companies. As a young systems engineer, the first management job I had was running the risk management process for one of my projects. So we have some unique roles here in risk management. So that's another one that they'll emphasize. I think more medium priorities would be all of the technical management processes, and then some areas that I think will use some terminology that you might not be familiar with. It's certainly things that even after a 40-plus career, until I really looked in detail at the handbook, I wasn't aware of some of the terminology. So life cycle terms and concepts, things like the difference between a waterfall, a incremental, and an evolutionary life cycle, how Agile fits into all of that. Um, let's see, system concepts, how INCOSE, the whole system science behind systems engineering. Again, areas you might not be working at, likely maybe not covered in an engineering class, or things that you wouldn't necessarily pick up on the job. So again, just things to exercise. Second big area, terms and definitions on Appendix C, and I'm going to say more about that in a second. And third area, there are some things called learning objectives. I'm going to show you where INCOSE provides those learning objectives. I'm going to show you what they look like and how they're tied to the handbook, and that will give you some areas to recommend as well. Ideally, you'd memorize 350 pages. I don't think many people can do that. So you're going to need to focus on these areas. And those are the ones I would take a quick look at, the morning before the exam or the day before the exam. This is our ISO 15288 lifecycle process. And so let me go through this a little bit. If you haven't seen this, the bottom right-hand part of this process, what's called the technical processes, section 2.3.5 of the handbook, that's what we think of as the V model. So it starts with concept definition, it goes into system definition, system realization, system deployment, and use. Within each of those four major sections of the V, right, INCOSE has broken that down. So you can see 2 processes within concept definition, 3 within system definition, 4 within system realization, 4 within system deployment. So you're going to immediately see some terminology, and it may be things that you don't know. So the difference between business or mission analysis, which applies to which, right? Stakeholder needs versus stakeholder requirements. And what's different about stakeholder needs in requirements definition versus system requirements definition, which happens in the next circle, right? What's a system architecture? What are the steps to go through for that process? What's defined? And the same thing with realization, what does it mean to implement a system? What does it mean to integrate? What are some of the key areas? Verification, validation. Throughout all of these processes, you want to know kind of what are the typical inputs, what are the typical steps in executing that process, what are the typical outputs produced by that process. So those are going to be part of your questions. So I think if you're like most people in the industry, you've done some work in the technical processes, you have some background of that. The top line, the technical management process, though, is going to be heavily discussed in the exam, especially risk management, but all of those activities, project planning, project assessment and control, decision management. Notice under technical management, when they say project planning, they're not talking about the planning that a project manager or program manager does. They're talking about the planning that a lead systems engineer or the chief system engineer or the system engineering manager on a project would do in planning the technical work of the project, basically planning the systems engineering activities. Same thing. So all of those activities, if you haven't had much involvement with management activities, those are going to be new to you. And so make sure you look at those and understand things like, well, where does earned value management fit? And how, when I'm making these measurements, what kinds of measurements am I making? What am I going to do with it? What are the main activities in quality assurance, et cetera? So again, that top bar, that technical management process, you want to focus on it. To a less extent, the two sets of activities on the left-hand side are going to get looked at. The top one in brown there is called agreement processes, and that looks at acquisition and supply. Acquisition is what do you do to acquire system elements from your suppliers and your vendors. Supply is what do you do working with your customers. And so there's some general discussions there. You'll find fewer questions on agreement processes in the exam, but it's something to be aware of, especially if you haven't been involved in those kind of activities. And then an area that's, I think, often troubling for people, the gray box in the bottom left, organizational enabling, project enabling processes. These are organizational-wide processes being implemented by somebody at the enterprise level. And again, some of this stuff we don't we don't necessarily do. So, if you see the words infrastructure management, if you weren't familiar with section 2.3.3.2, you may not know much about infrastructure and what that means and what the activities are that organizational people might undergo to manage the infrastructure. So again, useful to read through all of the handbook cover to cover, but spend some time. I think luckily the agreement processes and organizational project enabling processes will be covered in less detail. Most of the detail is going to be on the two reds that you'll see, the system definition, those three processes, and risk management, that processes. So that's where I would spend the bulk of my time. Any questions about ISO 15288 or kind of how that lines up with the handbook? Okay. So let's talk a little bit about terms and definitions. So one of the things I said is you really should know the terms that are used in the handbook in addition to knowing the processes on the previous chart. So if you go to Appendix C, you're going to find a complete list of all the terms and definitions, about 70 plus terms there. Again, unlearn the way your organization or your school use those terms. You need to know the definitions as per INCOSE. Also, it's not necessarily a definition you'd get out of ChatGPT or Copilot or some other large language model. Here's an example of the definition. Verification, confirmation through the provision of objective evidence that specified requirements have been filled. And a lot of the terms and definitions in the INCOSE handbook are going to actually come from ISO 15288, that standard. So nothing particularly challenging, except if you've worked in an organization that has defined verification differently, or maybe worked in an organization that just didn't even use that term, right? And so you would have wanted to look at the verification process and you want to know it. You would very likely on the exam be asked a question like you saw in the earlier sample questions we looked at, what is verification, or the difference between verification and validation, because that's an area that a lot of people get confused. Like the sample questions we looked at earlier on the exam, you're going to get a lot of answers that seem close and some that use terminology related to that process, but if you look carefully at them, it's not the right answer. Again, take a look. Be careful when you're on the exam. Be very careful when something is asking about definition. Read the question a couple of times. Make sure that you're following through. And the definition, the 70 terms go on for about 4 pages. And if I was going to memorize anything in the handbook, that's what I would mind, right? So someone's asking here in the chat window, highest priority system definition, right? Yeah, that's the right thing, and that's the focus, as we kind of said here, right? So this says, okay, system definition is going to be really important. Risk management is going to be really important. So on this 15288 chart, these 3 activities under system definition are going to be the most important processes to know thoroughly. I would want to know inputs and outputs of these and the typical what happens inside of each process here. There are some little input-output diagrams that you can look at in the handbook. And then risk management is going to be another important thing. Okay, so some other questions. Someone's saying they've joined. Where I can get the free System Engineering Handbook. So go to the INCOSE store. Okay, log into the INCOSE, go to the INCOSE store, and then you'll find that as one of the featured products, or you can put the handbook in the search engine and you can find the handbook that's there. If we have a second, I'll show that. Okay, and then you'll get a digital copy you could download. It's a PDF. Recognize that. Let's see, all the INCOSE handbook is copyrighted. I'm using a couple of select slides from there, but in general, you can't give somebody else your handbook. So even though you're a member and you could download it, you're not really supposed to share it with anybody else. Everybody's supposed to have their own copy. Okay, so that's Appendix C. Something else I want to talk about, there's something called the learning objectives, and I've given you the reference here for the learning objectives, and it looks like this. And so you can, if you look at it's only 2 pages long, right? So they're just the cover page, and then there's this. And this is actually what's organized. So we're now on the 5th edition, and you can see it's been organized. And so this is kind of a short list of what you are expected to have learned from reading through this section. So for example, in part 1, you should be able to identify systems engineering definitions, principles, and concepts, and you should define awareness level concepts of system thinking. In other words, you should have some basic idea of systems thinking. When they talk about things like awareness level here, what they're pointing to is the INCOSE Systems Engineering Competency Framework. So in the competency framework, it talks about different levels of understanding somebody might have about a topic like system thinking, for example. Awareness is the lowest level. Awareness says, I understand some basic ideas. So if you wanted to look more detail, what do they mean by awareness level concepts of system thinking, you would go off to the INCOSE Systems Engineering Competency Handbook. By the way, you can download that from the INCOSE store as a member, just like everything else. You can see things like the technical processes in part 2, the technical management processes in part 2, and the lifecycle models and concepts in part 2. Those are going to be covered more heavily on the exam. So the part of the handbook that you really need to know backwards and forwards is part 2. So that's going to cover all of the main kind of ideas. You'll get some questions on part 3, part 4, and part 1. But they're likely to be a lot less than the number of questions that you're going to be on part 2, part 2. And part 2 is much, much longer. If you look back here at our table, right, you can see part 2 covers all the technical processes and all the technical management processes. So there's lots and lots of processes here to be covered in part 2. So I think give you a number of different ways that you can look at it. Part 6, would that be covered? Yeah, it could be a question or two on part 6, probably not too extensive. So what's in part 6, let's look back here at the very beginning, right? And so you can see part 6 is case studies. It's not going to ask you something about a case study, but you may see some sort of analysis or discussion in a case study that's going to be referenced. So a typical question might be, if faced with this situation X, Y, Z, one a good solution is to do X, right? And then you would have seen from the case study that X was done or X not. So question here in the chat, does INCOSE accept involvement projects during graduate study as professional experience for CSEP? Yes, they should accept that as professional experience if you were applying systems engineering in the graduate studies. So I think put that down, explain that, and see how that works. The worst thing that happen if you fill out a CSEP application is they just say, no, you don't qualify and you have to get the ASEP. If you want your CSEP, but you either were told that you didn't qualify or that you don't qualify, you only qualify for the ASEP, it's still useful to get your ASEP now. And the reason why is if you're going to take the exam, take it while you're younger and fresher. I will tell you that as you get older and you get into your career, it gets tougher and tougher to study for and take an exam. Not only do you get other responsibilities like spouses or significant others and families and mortgages and other things like that, but you also have a job. So I always think if you can get the exam out of the way early, that's fine. Get your ASEP now, and then getting your CSEP will only involve filling out the application once you have your 5 years. But always try it. I would always if I thought it was close, I'd always put it down and see if I got accepted for it. They're not going to be penalized. All they're going to just do is say no if they don't like it. Okay, that's learning objectives. Okay, so let me give you kind of a suggested plan here. So this is kind of assuming you're working. Maybe you're going to devote every Saturday to this, or a couple of hours on Saturday and Sunday here. If I was doing this, I would try to study, make my study push in about 4 weeks, with about 30 hours or so. Week 1, I would study the system engineering foundations. That's going to help you and set you up for the rest of it. So I'd look at chapter 1, I'd look at chapter 2.1, I'd look at appendix B, which is the acronyms, I'd look at appendix C, which is the glossary. Okay, appendix C you're going to memorize later on, but at this point you might at least look for it. What you want to learn here, key concepts that's kind of shown there in that 4th column. What's systems engineering, what's system thinking, what's a system of interest, hierarchy, emergence, like what are all the life cycle stages, what does it mean to be a stakeholder, that sort of thing. Okay, so read the chapters. I think if you used to making flashcards, that's useful to just kind of remind yourself about, quiz yourself about terminology, especially. Sketch out the life cycle stages. There's some pictures in the textbook, and you need to be able to kind of do those in your head when you're taking the exam, and then reason through a question that might ask about whether this step happens before that step. Week 2, I'd look at chapter 2.3, system lifecycle processes. There's 4 process groups there. The structure of the life cycle that I showed you, the more complicated picture, look at agreement process, organizational enablement, technical management processes. So you just kind of understand how all the processes are connected and structured, right? So you should be able to build process group diagrams. You should summarize the purpose of each process. That would be another thing to put on a flashcard, right? And look at identifying some process relationship. What's the handoff between system requirements definition and system architecture definition, for example. Week 3, really get into chapter 3. Look at modeling, simulation, prototyping, interface management, architecture, some of the ILDs like reliability, etc., safety, interoperability, right? There are n-squared diagrams in the back of the textbook. If you're not familiar with that, you want to look at that. They show interfaces between processes or interfaces between components, right? You want to think about some of the analysis methods, because there may be analysis methods that you haven't been involved with in your professional career, right? And think about tracing things through the entire life cycle. What does that mean? And then week 4, check chapters 4 and 5. They're less critical, but you're still kind of looking at them. So things like tailoring and agile and MBSE, etc. And in week 4, since chapters 4 and 5 are a little shorter and not as critical, I would take all my practice exams there. Take them several times. If you find yourself having a problem, there are a number of people out there that sell practice exams. I'm not going to pick a winner and loser out of any of those, so I won't take sides, but I would say they're all reasonably good here. And think about incorrect answers. I say revisit the glossary. What I mean is now go back and really try right before the exam to just make sure you're familiar with all of the glossary definitions, right? You can redraw some main things like the life cycle model and V diagram. You should be able to draw this picture essentially from scratch. In other words, know where all the activities on this picture are. So that's kind of necessary. So I would do that. And right before I walked in the exam, I would probably read Appendix C, the glossary, over and over a couple times, just being familiar. If you really knew the glossary backwards and forwards, you have that. Say exam answers for practice exams may not be correct. Yeah, I've heard some people, they've taken practice exams and they gave an answer and the school answer wasn't really, they didn't really feel it's correct. So again, check the answers with CBOC, right? If you're familiar with large language models like Copilot or ChatGPT or Claude or Gemini, whatever your favorite one is, you could just actually set it up like a little tutor and say, ask me a question that might be on the INCOSE System Engineering exam, and then give an answer and let it kind of practice. So it wouldn't take too much to set up a large language model like that to basically be your tutor. But if it told you got the answer wrong and you felt competent, I would go look it up or force the large language model to give you the reference section when it tells you that your answer is wrong, and go reread that section, convince yourself. Large language models can hallucinate, and I've seen them say some of the wrong things relative to the handbook, and was able to confirm in the handbook what exactly is correct. Right. And then I just want to point out, someone said, reference every answer with a CBOC. There is an online free resource called the CBOC, the Systems Engineering Body of Knowledge. It's under cbocwiki.org. The CBOC and the handbook are not the same. Okay, in most places they are consistent. I don't know if that's everywhere, but you're not being tested on the CBOC, you're being tested on the handbook. So just make that distinction. I think some people believe, hey, well, the CBOC's free, I'll just look at it, I'll use that to prep. You're not going to get the full extent that you will by looking through the handbook from just the CBOC alone. A lot of the core sections are the same, but I would really go to the handbook for the definition. Again, good reason to join INCOSE. Okay. I'm going to leave you with one more chart, and I'll take any questions for the remaining time that we have here. So I want to point out, my group puts on a number of systems engineering and MBSE courses here at Caltech, and there's a URL there at the top that kind of gets you through that. The one that might be interested to you would be the Systems Engineering Fundamental course. This is a 35-hour course. You can take it live or on demand. We have a couple courses coming up. On demand means everything's pre-recorded and you watch videos and basically submit all your homework online there. If you take and pass our Systems Engineering Fundamentals course, you do not have to take the exam. So if tonight has convinced you that this sounds way too tough, an alternative would be to take the Systems Engineering Fundamentals course. We also teach MBSE and advanced ones. We also teach a course in transitioning MBSE models from V1 to V2 as well. And all those courses are both available live and on demand. Let's see, if you're considering taking a course, recognize that if you're working for a company, almost every corporate tuition program will pay for these courses. So they're priced to do that. And corporations typically like you to take these kind of courses, and especially if it's working towards something like your CSEP. So you can pay for that, so it won't be any money out of your pocket. And we don't require payment until the last day of the course, which means that you could apply for tuition reimbursement, get the approvals from your supervisor, take the entire course, and then at the very end put it on your credit card and get reimbursed by the company. You'd never actually be out any money. All of our instructors are practicing systems engineers. They are all active INCOSE members. They are all very familiar with the handbook, and we teach to the handbook. I'd like to offer all of you a little discount if that's something you consider. I will give you a 20% discount on any of our system engineering and MBSE courses, and the discount there in INCOSE 20 is there for you to use. We also do provide training to companies. So if you think your company could benefit by bringing system engineering training in-house, please reach out to me. My email's on the front. The URL at the bottom will also lead you to me. And we'd be happy to talk to you about it. When we teach a class for the company, we can also tailor that to the nature of work that the company does, any standards that they use. We don't have to follow INCOSE if they use a different standard, for example, as well. So that's my little pitch in terms of us, and if that's something you want. If you do want to take the exam, that's great. And I certainly want to support you in any way I can. If I can answer any questions now or later on, I'm happy to do that. That's why I put my email on the very front of the package here. and we're distributing this package to everybody. So with that, I think we have time for a few questions, if anybody has any questions.
Anyone
Do you have
have
any
any questions?
questions?
Yeah, anyone have any questions? Don't hesitate. You can type it or you can unmute yourself.
Well, he was very clear. I was very confusing. One of the two here.
Very clear. It's very clear. I just really hope that, when I take the exam can get through this before I take the exam. Oh, I
Okay.
saw a question.
People want me to show you how to access the System Engineering Handbook as an INCOSE member. I'm happy to do that. So let me throw my browser up here. So close off some of these windows. And so we go to incose.org. Okay, let me just expand that a little bit. Okay, and then log in. All right. So I've joined INCOSE, so I have a username and password, which will come up in just a second here. Oh, okay. So mine, it's already in the system, so it's logged in, right? Okay, so now I'm there. I'm going to go to the store. Right, see the store little shopping cart right up here in the top. So now I'm in the INCOSE store, or I could have gone directly there and then logged in afterwards. While my page is loading here, yeah, the View Pearson is an online proctor exam. That's correct. That's the View Pearson is the group that studies this. And somebody else is asking, is there any exam in the Caltech Systems Engineering course? We do have an exam at the end, but it is shorter. It's only 55 questions and it's open book. So if you can't pass an open book based on the handbook, then shame on you. It's open book. It's not timed. You can take as long as you want to with it. So that's our exam. A lot easier, and we don't charge anything for that exam. Okay, so I'm now in the online store. If you go in here, you can see there's lots and lots of documents here in there. There is, in the middle of the screen, is the System Engineering Competency Framework that I talked about. So if you want to know what does an awareness level look like for any of these topics, it's there. Right, I think some really interesting things. Letters to My Younger Self, I think, is an interesting book. These needs and requirements manual, that's one of the foundational ones, etc. Right, but you can see there's lots and lots of things. So just even having this there. There's a handbook tutorial here, right? But unfortunately, that's on version 4.0. The handbook 4.0 here is soft copy again, so the old version is still there. But this is where you really want. See this purple cover here in the middle? So you can do this, and if you're a member, right, you're going to do the soft copy, right? Now, if you're not a member, you can pay 90 bucks and download it, but I don't know why anybody would do that. It's only 180 to take it. So if I click on there, I'm now in the online store. It says here's the System Engineering Prague. The price is $0 for me because I'm a member. Tells me how big it is, right? And then I could go to Wiley if I was a non-member. And what I do is I add it to the cart, right? And so now it wants me to go back and log in. So just a second. Okay, so now it's got me logged in. And so now I add it to the cart. Okay, so this is like you're shopping at Amazon, right? Except in this case, it's free. I'm all done. I check out. Okay. And then I have to check one more time here. Right, there's no payment. It gives me my order. I have to process that. Okay, and so now I process the order. Okay, so now it's complete. Now I've done that, right? So I can go back to the online store. So if I go up here, right, under store now, I can look at my digital library. Okay, And so if I look at my digital library, right, these are all the things I've downloaded from the store. Give it a second to come up. So while we're waiting for it to come up, someone says his company's a cab member, but the colleague say he couldn't outload it. So there's different levels of cab member. So you're probably the level that doesn't get access to the store. So sorry for that. Okay, so this is my digital library. It's now opened up. You can see I've got certifications. This is where I'd see like my certification badge, etc. The INCOSE store is where all the things I've bought in the store or downloaded are there, right? You could download the whole store, but better here is just open it up. And now you can see here's all the things that I have downloaded over my lifetime in INCOSE from the store, right? And so if you look up here, here's the INCOSE Systems Engineering Handbook, right? And so now I could download it to my laptop, and now I would have a copy. Okay, hopefully that helps somebody who's looking for how to get that. Okay, other questions?
There's one more question about the ISO standard, by the way.
Okay, is the ISO standard for system engineering based on the INCOSE Handbook or CBOK? It's actually the opposite. The INCOSE Systems Engineering Handbook is based on the ISO standard. The ISO standard came first, ISO 15288. And then the handbook, instead of redefining terminology, where it could use a term from ISO 15288, it used that term. Also, it used that term, all the terms for the processes from 15288. By the way, the CBOK uses the same terms in the same way, in the same process, the same way, but both the handbook and the CBOK come from the standard, not the other way around.
Any other questions?
Okay, well, thank you for letting me share with you, and want to wish you luck in your preparations for the handbook.
Yeah, so all of us, thanks a lot for Professor Rick, your times and to share this excellent experience with all the members. It is recorded and I will publish it probably tomorrow at our community groups as well, at our YouTube channel as well. So the slide that you see is already published. You are able to download it right now at our user groups. The final thought is that, the Caltech course is very good course. A lot of my colleagues take that course and go straight to the ASEP, and they all have a very good feedback, especially, a lot of new things about the MPSC, enhance what the book is actually trying to convey the information for us. So again, thanks a lot for Professor Rick, and then we will end the webinar right now. Thank you.
Best of luck, everyone.
Bye-bye.